Good day, everyone. Welcome to Yebo Tutor on this beautiful, awesome Tuesday. If you are new, please don't forget to subscribe on our YouTube channel, Yebo Tutor. Please don't forget to comment on the comment section. Today, we'll be doing analytical geometry, hashtag road to final exams. Please don't forget to ask your questions in the comment sections, or also ask your questions in the WhatsApp group. We'll be free to also assist you. Please do join our WhatsApp group, Yebo Tutor as well, and also our Facebook page, Yebo Tutor as well. Please do join in. Let's just save maybe 2 minutes until 16:40. Then we can start with our tutorial today on analytical geometry. Today it's maybe 1 or 2 people to join, then we can start and hit the road. Epic. Let's start with our tutorial today. I want us to start by looking at the concept of analytical geometry. And let me just start from grade 11. So in grade 11, when we were introduced to analytical geometry, I'm going to start to just give an overview of analytical geometry. I think that's the easiest one. In your paper 2, it consists of 40 marks. So let's hit the road on the overview. So the first thing is that let's say we have a straight line AB, which are 2 points of the straight line, which is AB. We were taught about calculating the distance. And we're told that the distance D of AB is equal to square root of x2 minus x1 squared plus y2 minus y1 all squared. Bear in mind that A has a coordinate which is x. Let me just write it sort of like this. A consists of 2 coordinates of ax and y and ay. So in other words, A have the x coordinate and the y coordinate. So that's why we are saying AB, we're having x2 minus x1 plus y2 minus y1. That's the distance formula. That's our distance formula. I think you remember when we were plotting our graphs that, for instance, maybe this is our graph, and our graph is maybe like it's a parabola. Maybe it's like this. This point can be called point A. This point can be called point B. but bear in mind that this point have the x coordinate and the y coordinate. Okay, and also this one as well as the x coordinate and the y coordinate. Let's say here it's 3, here it's -2. So this one, the x coordinates maybe here, let's say 2. The x coordinate of this of a will be 2, and the y coordinate will be 3. So basically a comprises or consists of the x and the y coordinate. So both of them, they are there for you. So 2 and 3 are comprising the coordinates of a. So a, it's 2:3, and b now it's -2:0 because the y is 0 that side. So that's why. So for instance, let's say that we are given calculate the distance of AB. We know that when we are saying A, B, which means this one we have x1 and y1, and this will be x2 and y2. Okay, so now we know that our coordinate A is 2:3, our coordinate B is -2:0. So when they say calculate the distance of AB, that will be easy. Just say distance of AB is equal to square root of what is our x2. We say that the coordinate, which is the last one, when we are saying AB, that's where we're gonna have the x2 value. So we now go and then we check our x2. You can even say this is x2, this is y2, this is x1, this is y1. You can even say it so that you don't forget these simple things. So then our x2 in this case would be -2 minus what is our x1. Our x1 is 2. Then we square it plus what is our y2. We come here again. What is the y value of b? It's 0 minus what is the y value of what is the y1 of point A? It's 3, and all squared. Then you can get your answer. We know that -2 minus 2 is -4. -4 squared, we know that that's going to be square root of 16 plus, then we know that 0 minus 3, we know that it's -3, but when we square it, it's going to have a positive one, which is 9, and we're going to end up having square root of 25, and square root of 25 it's 5 units. So you'll be done calculating your distance. So I was just making an example, trying to illustrate x2, x1, y2, and y1. Now moving forward, so the first things which were taught in grade 11 is the distance formula. We're taught the distance formula. Now let's move forward. Now the second one which we were taught, we were talking about the midpoint formula. As the name is illustrating itself, midpoint formula. So for instance, we are having this line A and B. So this will be the midpoint. In other words, at the half, when you divide the line into two, the midpoint formula is illustrated then, because we are trying to get the midpoint coordinates. We have A and we have B, but we want to see the intersection, the midpoint. Then this is going to be our midpoint. So bear in mind that it's always like that. This is our midpoint. So what is the midpoint formula? The midpoint formula, M. Let me just do this. Midpoint formula M of AB is x2 plus x1 divided by 2 and y2 plus y1 divided by 2. So for instance, from the above one which we are doing, this small example which we are doing, if they ask you the midpoint of AB, we know that we're just gonna have, what is our x2? Our x2 is -2. So we're just gonna come here equal to -2. What is our x1? Our x1 is +2. Then we will say plus 2 divided by 2. Then what is our y2? Our y2 is 0 plus 3 divided by 2. Then we end up having 0 over 2, and 0 divided by 2 is 0, and 0 plus 3 is 3. The 3 divided by 2 is 3 over 2. So now, in other words, the midpoint of AB will be 0 is to 3 over 2. So the midpoint of this straight line, let me just do something. Just move that line. Oh, come on. Okay. So maybe let's just draw this straight line. Yeah. So the midpoint of this is going to be 0 and 3 over 2. So it's a coordinate. So in other words, when you're calculating the midpoint, you're going to get a specific midpoint coordinate of that a line which are told to calculate the midpoint. So basically, the midpoint formula is that I was just making an example by using AB. So the midpoint formula is this one. Always bear in mind that it's x2 plus x1 divided by 2 and y2 plus y1 divided by 2. That's the midpoint, our midpoint formula. Then the last one, not the least one, before we do more questions now, we have what we call the gradient now, calculating the gradient. The gradient of a line is what determines whether the gradient will be steep or it's not going to be steep. So bear in mind that on the gradient, it can be negative or it can be positive. And the gradient is so essential when we are determining the equation of these lines. For instance, this line AB, if we are told to determine its equation, the equation of the line, that will enable us, or it will enable us to be able to determine the equation, because we need that gradient. So now the formula of the gradient, which is represented by small letter A, let's just say gradient of AB will be y2 minus y1 divided by x2 minus x1. So that's how you can calculate your gradient. So that's the formula of calculating your gradient. So I'm still giving you the formulas and still having an overview on this nice topic which we are having right now. So after that, we move now on calculating or determining the equation. Let's just say determining the equation of a line. So determining now the equation of a line. So we have this formula which is y minus y1 is equal to mx minus x1, where m is the gradient, and x1 comma y1, it's a coordinate. Or is just a point which is in that specific line. So this is how we determine the equation of a line. When they say, when they ask us determine the equation of a line, it won't be hard because we use this formula, determining the equation of a line. Oh, sometimes they can just give you, which is y is equal to mx plus c. Still, m is still representing the gradient of the line. And after that, you can replace x and y by saying that you are having x and y as one of the coordinates in the line which you are told to determine the equation of the line. Then you can calculate the constant value c. Then after that, you can substitute back the constant into the original equation. Now, moving forward from that, we were taught now that in order for us to calculate angles, because sometimes they give you something like this, these are triangles, but they give you in a Cartesian plane form. So they this is A, let's just say A, B, and C. Then they can just say calculate the angle, which is the angle of inclination. Yeah, let me just say that. Let me just use the correct term. Let me just use the correct term. Let me just use the correct term. Angle of inclination. Big English. Okay. So the angle of inclination, let's just say tan theta is always equal to the gradient. So in other words, you must know the gradient so that you can be able to determine what is the angle of inclination of that line. So for instance, if you are given the angle, you can still determine the gradient of the line. So that will be also easy for you if you are able to determine the gradient of the line. That will be also easy for you. Now, let's move from angle of inclination now, and let's move to... So this is our angle of inclination. Now, this was our grade 11. Everything which I've done now the distance formula, the midpoint formula, the gradient formula. That's our question. Bear in mind that the gradient, let me just also do this, NB, which means note well, that the gradient, which is represented by M, is always equal when the lines are parallel. Bear in mind that if they tell you that AB is parallel to BC, automatically their gradient is the same. Automatically, the gradient is the same. Now, from that, now I want to come to what we call the perpendicular. Next week we'll be doing Euclidean geometry. I think you're gonna get familiar with that name, perpendicular bisector. So for instance, now this is our line AB. Then there's this line which is let's say D, E, F. Then it makes 100 perpendicular. 100. It makes 90 degrees. Sorry, that's our perpendicular bisector. So in other words, now this line AB, if it's positive, the perpendicular bisector is always this one. So when you multiply these two, when you multiply the gradient of AB times the gradient of its perpendicular bisector, which is DF, it always has to give you -1. Why? Because they are perpendicular to each other. They are not parallel to each other, but they are perpendicular to each other. Always bear in mind that when we're talking of a perpendicular bisector, they don't have the equal gradients, but when you multiply the product of the two gradient of the lines, they have to give you -1. So bear in mind that the parallel lines have the same gradient, but now when they are now in this case that they are perpendicular bisector, they are bisecting each other, automatically know that the gradient of AB times the gradient of the other line, the gradient of this line, the gradient of this line times the gradient of this line, they have to give you -1. That's what we call perpendicular bisectors. Then now I think I'm done with grade 11 now, and what is essential in grade 11, I'm done. Now let's move forward now to grade 12 now. In grade 12, we only add two things which are important in grade 12, and that is what we call circle centered at the origin, centered at the origin. Let me just say number 1. So the circle centered at the origin is this one, and it has a specific formula. Okay, this is the centered at the origin. Let's just say this is our A, this is our B. We know that this is the radius. Any line coming from the center to the circumference of a circle is the radius, or the radii if there are many. So now, what is the equation of center originated at the circle? It is that x squared plus y squared is equal to r squared. What is r representing? R is representing the radius. So in other words, r squared, this r squared. X squared plus y squared is equal to r squared. Please, this is an important equation. Then the last equation which I'm going to talk about right now is the circle which is centered which is centered not from the center, or let me just say circle which have the point not on specific, actually not on the center. For instance, let me just draw it so that you can see it. Yes, so maybe we have this point here. Yeah, maybe we have this kind of point that side. So the equation which is used is this one, that x minus a O squared plus y minus b. O squared must give you r squared. What is our r squared? Our r squared is still the radius, which is squared. So please keep these ones in mind. 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 Okay. I am done now. Let's now look at questions now. Let's now look at questions. Is there anyone with any question? If you have any question, please don't hesitate to ask on the comment section. Please don't hesitate to ask your question on the comment section so that we can be able to assist you and we can be able to assist each other. Please don't hesitate to ask. Please don't hesitate to ask. Now, let's start with our first question of the day. Let's start with our first question, which one I want us to do today. It's adapted from 2017, sorry. Grade 11. I'm going to start with the grade 11 questions because grade 11 and grade 12, they are the same questions, but they only have the circles in grade 12. Okay. So this is a nice question which is on our screen. It's a nice question which is on our screen. Let me read it. It reads as follows. Question 3. Question 3. A, which is a coordinate or which is a point, which is in our nice drawing here. Sort of like it's a kite, but it have many diagonals. Okay, let's go. A, where is A? This is our A with the coordinates -2 is to -5. Is then we are also having B, we also have C, and we also we have D. They are the vertices of a quadrilateral ABCD. We know that a quadrilateral is a four-sided shape, such that the diagonals AC is perpendicular to BD. So this is nice, perpendicular bisector. So when you are reading the statement, you must be also able to analyze and apply everything which you know that, okay, so they are saying that AC is perpendicular to BD. So what does that mean? That automatically means that the gradient of AC times the gradient of BD is equivalent to -1. Always. The moment you hear that they are perpendicular to each other, these two lines are perpendicular to each other, which means in your mind, let it ring that no, man, they are perpendicular, which means there is a perpendicular bisector that side. Now, such that AC is perpendicular to the diagonal BD at T. T is the midpoint, and it is also the intersection of both BD and AC. Analyze your question step by step. They told us that AC is perpendicular to BD, which means their product of their grandes must give us -1, and they are intersecting at point D. So in other words, point D is the midpoint of both AC and BD. It's the midpoint. Yes, it is the midpoint. It's the intersection point of the two lines. Now let's continue. Now then they give us the equation of BTD is given by 2y plus x equal to 18, and we are given that AB is equal to 15 units. This is nice. This is nice. Let's look on our 3.1 now. On 3.1, determine the gradient of line AC. Determine the gradient of line AC. This is straightforward because we know that initially in our statement they told us that AC is perpendicular to diagonal BD. So the moment they are perpendicular, which means their product must give us -1. So since that's the case now, determine the gradient of line AC, we must just know the gradient of BD. So since we are given the equation of BTD to be 2y plus x equal to 18, let's determine the gradient of the line, this line. So how do we determine the line? So since we are given 2y plus x is equal to 18, we know that an equation must always be y equal to mx plus c. So let's make y the subject of the formula. sorry. Okay, so let's now make this y the subject of the formula, because we know that it's always the case that it's in this form. So let's go now. We transpose x to that side, so we have 2y is equal to negative x plus 18, but we want y, not 2y, so we divide both sides by 2, we divide all both sides by 2. Then we have y equal to negative 1 over 2 x plus 9. So this is the equation of b. It is the equation of BTD. So now, what is the gradient of the line? We know that the coefficient of x is always the gradient. It's always the gradient. So in other words, the gradient of BTD, or let me just say BD, is equal to negative 1 over 2. But that's not what we are asked. We are asked to determine the gradient of line AC. And we know that AC and that one, they are perpendicular lines. They are perpendicular to each other. So how are we going to do, and how are we going to handle that? We're going to handle it like this now. Since we know that the gradient of BD is negative 1 over 2, so we say that the gradient of AC times the gradient of BD is equal to negative 1. We say that perpendicular bisectors. Okay, so you can even give in your reason that perpendicular. Okay, I'm just do this. So you can just write that AC is perpendicular to BD. We were given that. You can reason on your own. What is the gradient of BD? So MAC times negative 1 over 2 is equal to negative 1. We want the gradient of AC. So it will be negative 1 divided by negative 1 over 2. Then we end up having the gradient of AC equivalent to 2. All of this is not essential. If you understand, I was trying to do this so that you can know where is the final answer coming from. Since they told that AC is perpendicular to BD, so which means their gradient, the product of their gradient must give us negative 1 automatically. So I was just doing this so that I can illustrate to you and you can be able to see it, that if we multiply the two, we must get this certain outcome. Okay, so we are done with our first question. We answered it and we say that the gradient of AC is equivalent to positive 2. Now they say determine the equation of AC in the form of y equal to mx plus c. So look at this diagram. We have AC and we already know the gradient of the line AC. So now we can calculate 3.2. So now we can be able now to calculate the equation of this line, because in order for you to determine the equation of the line, you must have one coordinate of that line or one point of that line and the gradient. So we have the gradient as well as the point. So that's easy. So I usually love and I usually ask students to use y minus y1 equal to m x minus x1, because if you use, they are the same. These two equations, they are the same. These equations are the same. Even this equation, which is y equal to mx plus c, they are the same. But I usually say to people, use this one, which I used right now, not this one. Why? Because that sometimes you might forget to substitute back the value of c and have a proper equation. So when you're using this one, we know that our gradient is positive 2, and we know that the point A we are given negative 2 is to negative 5. So we can be able to substitute. Oh, let's go now. Y minus, what is our y1? Our y1, it's negative 5 equal to positive 2. X minus, what is our x1? Negative 2. Come on, let's go now. Y plus 5 is equal to 2x. Do this. Okay, hallelujah. 2x, then 2. This is negative and negative, so that's positive. So you're gonna have positive 4. Then we transpose our 5 to the left hand, to the right hand side. So you're gonna have 2x plus 4 minus 5, and we end up having y, which is equivalent to 2x minus 1. So the equation of line AC is y equal to 2x minus 1. Y equal to 2x minus 1. Now, let's move forward to 3.3. Let's move to our question 3.3. If the equation of the line AC is y equal to 2x minus 1. So, they are verifying our answer that our answer is right. Calculate the coordinates of t. Where is t? There is t. We can see that t is the intersection point. Or in other words, the point t has the coordinates. When we are looking on the line AC alone, the coordinates of t are equivalent on the coordinates of t as well of the line BTD. So the first thing which I can always advise to do, that we can say that since they are intersecting to each other, which means that these two equations are equal. So let me just write this. Let me just say y equal to, we say the first one is negative 1 over 2 x plus 9. That is for B. Let me just write here. This is for B, BD. And let me just, this is equation 1. Then you also know that the line AC is equal to, what is the, for line AC? Line AC, we said it's 2x minus 1 AC. So this is our equation 2. So since y and y, we can just say that equation 1 is equal to equation 2. We equate the equation, then we substitute now. Negative 1 over 2 x plus 9 is equal to 2x minus 1. Then negative 1 over 2x minus 2x is equal to negative 1 minus 9. So negative half minus 2. What do you get when you say negative half minus 2? You get negative 5 over 2x, which is equivalent to negative 10. Then you solve for your x. This one and this one will cancel each other. Then you're left with your x. Then when you're using your calculator, you get your x to be equivalent to 4. So now we have t 4 is to y. So now we want the value of y. So we can substitute x equal to 4 in, maybe you can say equation 2. Please write these small things, this small English, so that you can direct the examiner, give him or her interest to mark with joy your paper, because you see that you know what you are doing. So now we are substituting in our equation 2. So wherever we see x, we have to put 4 so that we can have the value of y. So y will be equivalent to 2 times 4 minus 1, which is equivalent to 7. So therefore point T has 4 is to 7. So that's our coordinate, which is 4 is to 7. We have the coordinates 4 is to 7. Why am I saying that? Because T is a common point of both two lines. Okay, it's a common point for both two lines. It's a common point for both two lines. Please don't forget to ask your questions if you have one. Please don't forget to ask your question. Let's now move forward. Let's now move forward to 3.4.1. If ABCD is a kite with AB equal to BC, which means AB is equal to BC, which means they are equivalent. The distance between the two is the same. So from AB it's 15, also BC is 15. Wow, that's nice. That's nice. Now, determine the coordinates of C. Where is C? Where is C? Where is C? Here is our C. Wow. There is our C. There is our C. There is our C. So as always, we know that now we already know the coordinates of T. That's the midpoint. So there's this nice formula which says xm is equals x2 plus x1 divided by 2. What is xm representing? It's representing the x coordinate of the midpoint. So we can see that AC and T is the midpoint of that line. So that automatically tells us, no, this formula is familiar. And we have ym, which is equivalent to y2 plus y1 divided by 2. Ym is representing the midpoint. So in other words, the midpoint formula, you still remember that we said that the midpoint formula is x2 plus x1 divided by 2. Then there's a semicolon in between, and we have y2 plus y1 divided by 2. So basically, when we have that, now we can just say xm, ym. So these are our coordinates of the midpoint. So now, since we know that our t value, we calculated t value to be 2:, we calculated to be 4:7. So this is our xm and this is our ym. So come on, let's go now. Now we're gonna look at A and C now. So what is our xm? Our xm is 4 equal to, what is our x2? Our x2, I can say my x2 is the one which you are calculating. And what is our x1? Our x1 is the x coordinates of point A, which is negative 2 divided by 2. Cross multiply, that's 8 equal to x2 minus 2, then transpose, then you end up having x2 equal to 10. x2 equal to 10. Let's come to that side as well. What is our ym? Our ym is 7 equal to, the moment you say x2 here, the moment you make x2 the subject of the formula, also this side also for y, it must be y2, so that the coordinate is equivalent. What is our y1? Our y1 is negative 5. You divide by 2, you cross multiply, and we have 14 equal to y2 minus 5. You transpose your constant, and it will be 14 plus 5, then you get your 19 equal to y2. So basically, your coordinates of t will be 10:19. So those are your coordinates. 10:19. So basically, point C is 10:19. This is nice. So to summarize, what I did is that I just used this nice formula. Let me just highlight that so that you also remember that when you have the turning point, when you have the midpoint, you are able to determine the coordinate of the corner point or another point, since you know the point of the coordinates of the point of the midpoint. The midpoint coordinate, sorry. Now let's move forward now and do our 3.42. 3.42. On 3.42, they are saying that calculate the length of BT. Where is BT? BT here, here is BT. We know the coordinates of A and T. We know those coordinates. We know the coordinates of T, and we also know the coordinates of A. So you can calculate the distance of A, T. So we know that the distance formula says that x2 minus x1 all squared plus y2 minus y1 all squared. 80. So the moment it's 80, which means this one is to x2 and y2, x1 and y1. So come on now, let's go. So we're gonna have, let's do this. We're gonna have 4 minus, what is the x1 of A? It's negative 2. Negative 2 all squared plus, what is our y2? Our y2 is 7 minus 5 all squared. Minus 5 all squared. Then when you can use your calculator. When you use your calculator, you're gonna have root of 180, and root of 180 is approximately 6√5 units. Please don't forget to write this as your SI unit. So we have 6.5, because we want to determine the coordinates of BT, and we don't know the point of B. That's why actually we are doing in this format. That's why we are doing in this way. So now come on now, we know that let's just say in triangle ABT, triangle ABT, oh I'm sorry, Then in triangle ABT, let me just show this again. So I started by calculating the distance of AT and using the distance formula x2 minus x1 all squared plus y2 minus y1 all squared all under the root. Then after that I substituted the values and I got 6 root 5 units. Now in triangle ABT, now I want to determine the length of BT. How are we going to do that? We know that that's a right angled triangle. So since it's a right angled triangle, we can apply the Pythagoras theorem. And with the Pythagoras theorem says that AB squared is equal to BT squared plus AT squared. This is R squared for those that are used to R squared. This is your y squared, this is your x squared. For those that who are used to x squared, r squared, this is our Pythagoras theorem. Pythagoras. So come on, let's go now. 15 squared is equal to, we want BT, and we know that 80 is 6 root 5 all squared. Now we make BT to be the subject of the formula. So BT squared will be equivalent to 15 squared, because we're going to transpose this one to the left hand side. So it's going to be 15 squared minus 6 root 5 all squared. Then we make BT the subject of the formula, not BT squared. So we square both sides. Then we are left with BT, which is equivalent to 15 squared is 375. Then you square, and you just use your calculator automatically from that, so that you don't get much challenges. Then when you use your calculator, you're gonna get 3 root of 5 units. So that's our length BT. Let me do this so that you can get refreshed. So we say that initially, since they say that calculate the length of BT, we don't know the coordinates of B. So we can't use the distance formula, just say the distance of BT, because we don't know the coordinates of B. So what do we know? We know the coordinates of T, and we also know the coordinates of A, but we don't know the length of AT. So we started by determining the length of AT using the distance formula. Then we got, and we arrived here to have 6.6 root 5 units. Then after that, now we know that triangle ABT, it's a right angle triangle. You can see that 90 degrees there. It's a right angled triangle. So since it is a right angled triangle, we can apply the fact that we can use the Pythagoras theorem. And using the Pythagoras theorem, we know that Pythagoras theorem is, we're going to say r squared equal to x squared plus y squared. What is our r squared? Our r squared is the hypotenuse. What is our x squared? Our x squared is the adjacent side. What is our y squared? Our y squared will be our opposite squared. So now we did that by the Pythagoras theorem. Then we can be able to attain BT to be equivalent to 3 root of 5 units. You can leave it in said form, or you can simplify it, and you can get approximately 6.71 units. Then now let's move now to, please don't be afraid to ask any question. If you have any question, please don't be afraid to ask any question. Do ask your question so that we can assist you as well. Okay, thank you. Now let's move forward now. Moving forward now, they're saying write down the length of the radius of the circle passing through points BCT. Where is BCT? BCT. There is a circle. Write down the radius. We know that the radius is the, you know that the radius is the line from the center. So let's say this is our circle. From the center to the circumference, that's our radius. So if they say BCT, we can say that we can make, after we have calculated there, we can see that we can, let me just draw it here. Gosh, my circle is not good. Okay. My word. Okay. This is our circle. We have BC. Yes. Yes. Then this is our, where is BC? BC, and that is our T. So now write down the length of the radius of the circle passing through the point. So we can say that BC is a diameter. Why are you saying that BC is the diameter? Because we know that it's just the converse angle in a semicircle. Don't forget to write these reasoning question answers, because it's a converse of the same semicircle. Please don't forget those reasoning. So if this is a diameter, so we can be able to determine the radius, and we know that the radius, the entire line is the diameter, but the radius is the line from the center to the circumference. So we know that our radius will be equal to BC divided by 2. What is our BC? What is our BC? BC is equal to 15. Remember, they say that here initially that AB is equivalent to BC. So since we were told that AB is 15, our BC is also equivalent to 15. Let me just write it here so that you don't get confused. So AB is equal to BC is equal to 15. So bear this in mind. So now we can determine our radius, and we get 7.5 units. So our radius of that question is 7.5 units. That's our radius. Now let's move forward. Let's move forward to the last question. Let's move forward to the last question in grade 11 past paper. Let's move forward. Let's do our question 4. Please, if you have any question, please do ask. If you have any question, please do ask. Please ask if you have any question. So this is what I was talking about. This is our circle. Then our diameter is BC. Why did we say, or why did you assume that BC is the diameter? Because of this reason, that it's a converse angle in a semicircle. Then after that, we can be able to determine our value of the radius, because the radius is the line, or is the length from the center to the circumference of the circle. Then we were able to find 7.5 units. Now let's move to question 4 now. Question 4 now, it's saying that on our question 4, C, where is point C? Oh, we are having this point C. C, we already know that the y value at point C is 0 because it's located on the x-axis. So analyze it before you even attempt to answer the question. Analyze the information which are given. Okay, let's go. C is a point on the x-axis, which means C, its x is to 0. For the fact that it's on the x-axis, we are also given A, we are also given B at the vertices of the triangle, and AB intersects the x-axis at E. Here, then we are given alpha. Then they told that ABC, where is A? ABC is theta, and BEC it's our alpha. Now calculate the gradient of AB. We said earlier 4.1, the gradient of AB is always equal to y2 minus y1 over x2 minus x1. We have AB, so we're gonna have 12 minus 3 divided by 4 minus 5. Then we end up having the gradient to be 12 minus 3, that's 12 plus 3, that's 15. Then 4 minus, that's 9. Then we can simplify this, then putting 3 there, that's 5 over 3. So the gradient of AB, it's 5 over 3. You have your marks. I'm sorry guys. Okay, so calculating the gradient of AB, we know that y2 minus y1 over x2 minus x1 must be able to give us, now we substitute the values, 12 minus 3, then 4 minus 5. Please don't forget to write this subscript AB so that we can know what is the gradient, which gradient of that of which line are you calculating. Then we're able to get 5 over 3. Then we were able to get 5 over 3. Then we were able to get 5 over 3. Now, let's move forward. Let's move forward. Let's move forward now. Let's move forward. Let's move forward now. Looking at 4.2. On our 4.2, let's read it together. Calculate the coordinates of point E. They want this coordinate of point E. They want the coordinates of point E. They want the coordinates of point E. So we can see the line E is on the line of AB. There is this term which is called collinear. They are collinear on this straight line. So this point E, which we are having here, let me just say that point E, we can see that E is on the x-axis. So automatically our y it's 0. But now let's be able to determine the equation of line AB before we can be able to attempt to answer. Before we even attempt to answer for the coordinates of E. So since it is on the x-axis, we already know that the y value is 0. So now let's first determine the equation of that line. So we said in order for us to determine the equation of line AB, we have to have y minus y1 equal to mx minus x1. What is our gradient of AB? We have calculated it to be 5 over 3. So we have y minus me. I'm going to choose point B, and point B, it's going to be 4 is to 12. So you can choose point A or point B, but I choose point B. So we're going to have, what is our gradient? It's 5 over 3 x minus, what is our x1? Our x1 is 4. So we're going to end up having y equal to 5 over 3 x minus 20 over 3 plus 12. Plus 12. Then our y will be equal to, using your calculator, negative 20 over 3 plus 12. Negative 20 over 3 plus 12. Negative 20 plus 12. That's 5 over 3 x. Just do this. I'm trying to check on my calculator. Check on my calculator right now. Negative 20 divided by 3 plus 12. Then we have 16 plus 16 over 3. Then we have 16 over 3. Okay. So we have 16 over 3. Then after that, this is our equation of line AB. So since that is our equation of our line AB, now let's determine now the coordinates of E. We know that E, its x is to 0. So where there is y, we'll put 0. So we're going to have 0 is equal to 5 over 3 x plus 16 over 3. Then let's solve for x. We know that negative 16 over 3 will be equal to 5 over 3 x. Then divide by 5 over 3, divide by 5 over 3. Then using your calculator as well again, you attain your x value to be negative 16 over 5. So therefore, the coordinates of point E is negative 16 over 5 is to 0. Just to rewind again, we started by determining the equation of the line. We started by determining the equation of the line AB. Then when we are done, we find out the equation of the line is y equal to 5 over 3x plus 16 over 3. Then after that, now since we know that E is on the x-axis, that automatically tells us that the y value of point E is equal to 0. So now we only have to calculate the x value alone. So how are we going to do that? Wherever we see y on our equation of the line, we place it with 0. Then we solve for x. Then we make it x the subject of the formula. Then we end up having x is equal to negative 16 over 5. Then don't forget to write in a coordinate point that point E it's negative 16 over 5 is to 0. Now let's do 4.3 now. 4.3. On 4.3, they are saying that determine, let me just do this. They're saying determine the size of alpha. Where is alpha? Alpha is here on the line of AB. So that's when we're talking about angle of inclination now. So how are we going to solve that? So the tan alpha is always equivalent to the gradient of AB. So tan alpha is equal to 5 over 3. Let's solve for alpha now. We know that alpha will be equal to arctan of 5 over 3. Then you use your calculator now. Then you get 59 degrees if you use your calculator. Because they said that rounding off to the nearest whole number. So to the nearest whole number, this is what we want, 59 degrees only. Now, let's move on to 4.4. On 4.4, they are saying if theta is 76, where is theta? We're given that theta is 76 degrees, okay. Let's move forward. They are saying now determine the equation of the line through A. Where is A? This is A, parallel to BC. Parallel to BC. Now, let's determine this angle C first. Let's determine the angle C first. How are we going to determine that angle? We know that BCX is equal to theta, which is 76 degrees, plus alpha, which is 59 degrees. Do you see that triangle? BCE. Okay. Why? It's the exterior angle of a triangle. Maybe you don't see that. Let me just draw this triangle here so that you don't get confused. Let's say this is the triangle. Okay, we are having A here. We're having alpha. We're having theta here at point B. We also have point C here. Okay, so this angle is equivalent to this angle, this angle. This is the angle which we are saying BCX, guys. This is the angle which we are talking about. This angle is equal to these two, this angle, this angle, this angle. We're not talking about this angle. When I said BCX, I'm saying BC and the x-axis. So BC and the x-axis is this angle, and it is equivalent to the two opposite interior angles, alpha plus theta. So 76 plus 59. So that's where the exterior angle of a triangle which we are talking about is coming from. Please also don't forget to write these reasons when you are writing your test. Okay, let's move forward from that. So now 76 plus 59, we use our calculator now and we get 135. So that is the angle of that line. Why are we calculating that angle? We are calculating that angle so that we can be able to determine the equation of that line through A. Let's now determine its gradient. We know that now tan of 135, you use your calculator, is equal to gradient of BC. Because that we say that they are parallel to BC. So since they are parallel, we say that parallel lines have equal gradients. So having these equal gradients, we're going to have tan of 135 and tan of 135 is equal to negative 1, which is equal to the gradient of BC. Why? Because we are having the lines are parallel to each other. Now let's determine the equation now, because they are going through point A. And our point A, it's negative 5 is negative 3. So we can use the equation y minus y1 equal to m x minus x1 all divided by, now let's substitute. So it's going to be y minus minus 3 equal to, what is our gradient? It's negative 1, and it's x minus minus 5. Let's solve it now. Y plus 3 is equal to negative x plus 5. Then y is equal to negative x. Then 5 minus 3 is positive. Is it going to be plus 3? Let me just check so that I see if I didn't do mistake. Oh, okay. It's going to be plus here, but it's going to be negative this side. Sorry, because negative times negative is positive 5, but positive times the gradient, which is negative, you're going to end up having negative 5. Please forgive me for that error. Negative 5 minus 3, then you end up having the equation, which is negative x minus 8. So this is the equation which they want. So just to recap with you guys, initially we started by calculating that angle of that line BC so that we can be able to determine its gradient. So we calculated that angle and we figured that it's going to be the exterior angle of the triangle. So having that, and we find out it's 135 degrees, we were able to calculate the gradient of BC. Then after that, we got the gradient to be negative 1. And they say that it's going to pass through point A. So we'll take that point A and substitute in our equation, which we know y minus y1 equal to m open bracket x minus x1, so that we can be able to determine the equation of the line. Then we substitute the point and we end up having this gradient. We end up having this equation. Is there anyone with any question? Is there anyone with any question, guys? Please feel free to ask any question if you have one. Is there anyone with any question? Okay, seems like we are on board together. So that was our grade 11 work. I covered everything, and I always advise that know everything in that question. It will really be grateful for you. Now, let's look at our grade 12 paper now. Let's look at our grade 12 paper. Oh, yes, this is our grade 12 paper now. Is there any question? Is there anyone with any question? If you have any question, please don't hesitate to ask. If you have any question, don't hesitate to ask. Let us assist each other. Okay, now let's go to grade 12. I want you to notice that these questions, they are almost the same. They're almost the same. Let's do grade 12 as well. Bear in mind that analytical geometry, on your paper 2, it consists of 40 marks, plus or minus 40 marks. 40 marks analytical, 40 marks trigonometry, 50 marks Euclidean geometry, and 20 marks for statistics. Yes, statistics. Now let's do question 3 now on grade 12 work now. Now in the diagram, A, B, and C are points on the Cartesian plane. F, which is, where is F? Where are you, F? I can't see. Oh, here is F. Here is F. And G are points on the line AC. Okay. Such that AF is equal to FG, which means F is the midpoint of AG. Analyzing your question just like that, by just reading the question which you are given, you are given that AF is equal to FG, which means they intersect on point F, which means that's the midpoint. Okay, now, cool. And E is the x-intercept of AB. So if it's the x-intercept of AB, which means the y value of point E is equal to 0. So that's how you analyze your question. Now, let's go now to 3.1. Calculate the equation of AC in the form of y equal to mx plus c. Where is AC? This is our AC. In order for us to calculate the equation of that line, we must know the gradient of that line. So how are we going to do that? How are we going to do that? We're going to do that by simply using the equation, the gradient of FC, because a straight line have the same gradient. Always, it have the same gradient. So the gradient of FC is going to be equal to y2 minus y1 over x2 minus x1. What is our y2? Our y2, we said FC, so we have to look on C now. Where is our C? Oh, God, help me. Okay, so we're going to use this equation of a gradient. Where is our C, guys? Our C is negative 4 minus what's our y? Our y of f, it's 3.5. 3.5, it's 2 times 3, it's 6 plus 1, 7 over 2. Just convert 3.5 to an improper fraction. Or someone was going to just write 3.5 in a decimal format. Then we have 8 minus 3. Then just use your calculator. Then using your calculator, you're going to end up having negative 3 over 2. That is our gradient of line FC. Then after we are not yet done, because they say determine the equation of that line AC. So what do we do after that? We determine the equation y minus y1 is equal to m x minus x1. Let me just take point C. I love point C. Someone would take point F. So let me just say C, which is 8 is to negative 4. Come on, let's go now. So we're going to have y minus 4 equal to, what is our gradient? Our gradient is negative 3 over 2. Then x minus, what is our x1? Our x1 is 8. Then y plus 4 is equal to negative 3 over 2 x. Then negative 3 over 2 times negative 8. That will be negative positive 12, if I'm not mistaken. Yes, that will be positive 12. Then substituting, making y the subject of the formula, end up having negative 3 over 2x. Then 12 minus 4, because this positive 4, when you transpose to the left right hand side, it's going to be negative. So we're going to end up having positive 8, sorry, because 12 minus 4 is positive 8. So this is our equation of the line AC. That's the equation of the line AC. Please don't hesitate to ask any question if you have one. Do ask your questions, guys. Please do ask your questions. We are here for you. Even you can ask in the group. You can ask on the comment section as well. You can ask on the comment section as well. You can ask on the comment section as well. Okay, let's move forward to 3.1.2. So on 3.1.2, they said calculate the coordinates of G. Where is G? Oh, there is G. Okay. If the equation of BG, where is B? If the equation of BG is 7x minus 10y equal to 8. This is also simple. Why am I saying that? Because let's look at point G. Point G is located in both line BG and both AC. So that will be easy, which means G is a point of intersection. G is a point of intersection. So if it is a point of intersection, let me just write the equation of BC. Let me just say BG. What is the equation we are given? That is 7x. We're given that it's 7x minus 10y equal to 8. So let me just say this is our equation 1. Then now let's look on the equation which you calculated of AC. We say that on our equation of AC we have y equal to negative 3 over 2x plus 8. That's our equation 2. Why are we doing this, guys? Point G, we said it is the intersection of both two lines. So if it is the intersection of two lines, which means the coordinates is situated, which means the equations of those two lines, they are equal at that point because the point is the same. So now let's solve. Now we can see that we can substitute equation 2 into equation 1 because we have y here. So wherever we see y, we have to put negative 3 over 2 x plus 8. So let's go 7x minus 10 negative 3 over 2 x plus 8 is equal to 8. Okay, let's solve our x. This will be negative 5 times negative 3, that's positive 15 x. Then negative 10 times positive 8, that's negative 8, which is equal to 8. Then 7x plus 15, 15 plus 7, 15 plus 5 is 20, which means we're going to have 22 x equivalent to 8 plus 8, we have 88. Then we divide both sides by 22. Then we have our x coordinate to be, we use our calculators as well. Now x value is equivalent to 4 if you use your calculator, because it's 22, 22, I think it's 44, then from 44 it's 66, from 66 it's 88. Yeah, so it's x equivalent to 4, but I always advise that use your calculator. Use your calculator when you reach there. We have the x coordinate now of g. We want now the y coordinate of g, so we can substitute x equal to 4 in equation 2. You can substitute the x value in one of these equations. Me, I choose the second equation. Wherever I see x, I have to replace with 4. So our y will be equal to negative 3 over 2 times 4 plus 8. So y will be equal to, that will be 2 times negative 3, it's negative 6. Negative 6 plus 8, we get positive 2. Use your calculator when you reach that stage, please. So therefore point G has the coordinates of 4, 2. So those are the coordinates of point G, guys. Please don't hesitate to ask any question. We are here for you. So the coordinates of point G, it's 4 is to 2. All right. Now let's move to 3.2 now. 3.2. 3.2, they're saying show by calculating that the coordinates of A is 2 is to 5. Where is A? Here is A. Show that the coordinates of A is 2 is to 5. Okay. How can we show that the coordinates of A is 2 is to 5? This one is not hard. Why? We know that AF is equivalent to FG. And now we know the coordinates of point G. So we know that since F is the midpoint, the moment we see that AF is equal to FG, that makes point F automatically be our midpoint. So since F is our midpoint, there's this nice formula which we say that we can use that says that XM is equal to X2 plus X1 divided by 2, and YM equal to Y1, Y2, sorry, plus Y1 over 2. Now let's go for it. We know that our midpoint, it's F. And the midpoint F, it's 3 is to 3.5. 3.5, it's the same as 3.5. So now this is our XM and this is our YM. Always analyze the question in the way I'm analyzing for you, that the moment that we're told that AF is equivalent to FG, we have to already know that automatically point F is the midpoint there. So this is going to be XM and this is going to be our YM. So we're going to substitute there and put our 3 is equal to, now let's look at our point G. We said G is 4 is to 2. So X2 plus 4 divided by 2, we cross multiply, we have 6 equal to X2 plus 4, and our X2 will be equal to 6 minus 4, which is equal to 2, which is equal to 2 always. Now let's now come and solve this side. Let's solve for the y2 as well. If you said x2 here, we also have to find y2 on the other side. So we said our gradient, it's 3.5, which is the same as 3,5 is equal to y2. What is our y1? Let's look at the y value of g. The y value of g, it's 2. Divide by 2, then 2 times 3.5. 2 times 3.5, it's 7. So y2 plus 2. Then transpose 2 to the left-hand side, you're going to end up having 5 is equal to y2. Come on now. So now we can now say, conclude that therefore A is 2 is to 5. So now we can conclude that A is 2 is to 5. Please forgive me, I'm forgetting to bring this screen back again. Let me just come back again. So first, initially, we say that since F is the midpoint of AG, since F is the midpoint of AG, since F is the midpoint of AG, we are able to determine using this nice formula. Please don't forget this formula. It's nice because if you know the midpoint, you can be able to determine the coordinates. So now determining the coordinates, we say that automatically moving from that point, we substitute the values of our midpoint, which is F. Then we ended up with x2 is equivalent to 2 and y2 is equal to 5. Then automatically we have showed that our point A is equal to 2 is to 5. Then you get your easy 2 marks. 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 Let's have a 1 minute break. 5 minutes break. Then we'll come back again and finish the rest question. Dancing,